Welcome to this episode of the xLM Continuous Intelligence Podcast. My name is Anand Rajan. I'm your host. And with me here today is Tanay Agarwal, who's a data scientist and a senior AI/ML engineer at xLM. Today, we'll be delving into the realm of what we call predictive analytics. What is predictive analytics, you may ask? Well, imagine if you could foresee the future, understand trends before they really unfold, make decisions not just by your intuition, but based on real data-backed insights. That's the power of predictive analytics. It's kind of the art and science of using historical data, statistical algorithms, machine learning to predict what's coming next. From forecasting sales to anticipating customer behavior, predictive analytics is really transforming industries, helping businesses make smarter, faster decisions, and stay ahead of the curve. Today, we'll explore how xLM in particular is making this a reality with one of the projects called Vikalpa, where they're converting data from just being descriptive to really predictive. So with me here now is Tanay. Tanay, this project that we're going to talk about, it's enabling predictive analytics through automation agents that are GxP compliant. Now, that's quite a mouthful, but just for the sake of our listeners, can you throw some light on what the biggest challenges are with the status quo in the industry that prevails today, and what really warranted this endeavor? And can you also talk about what real world problem that this project is aiming to address?
So when it comes to the status quo, we are still seeing a lot of traditional old school methodologies being followed in the industry. You will always have an analyst who will keep on parsing and making different analytics on an Excel sheet, what people usually call it as an advanced Excel. And this process is a lot of repetitive and manual intervention again and again by an analytics group or a person who just does analytics, and it's not exactly efficient and it keeps on getting prone to human errors. That's the current status quo because, hey, who can give a better touch than a human? That's a saying that keeps on going in the industry.
Got you. So this project, right? Can you describe what the framework was, or what the overall architecture was used to kind of solve the problem?
Yes. So right now we have used automation, AI, and agentic frameworks to put it precisely, to automate this entire process to make it streamlined. You don't have to keep on passing different Excel sheets. You can actually get sensors data real time. You can collect your data. We have our entire system that will ingest, enrich, and create different analytics and visualizations for you. So I can go about sharing my screen for a brief moment to give an example of how things work.
Sure.
So here we have our continuous temperature mapping page. So the application, you can actually go about creating different dashboards. You have to just follow a simple series of steps to create your own dashboard. So we can have it, for example, test. I can select a date range. I can select a time period. Let's take it a larger data set. I can go forward. I can either choose to provide my own data set, or I can take the ones that we already have ingested in the cloud. So we can upload one of the files over here. We can go about verifying it. We can similarly provide different grouping relations. So we have grouping data over here. We can also provide temporary sensors information. And then afterwards, everything is done. We can go about submit, and that's it. You don't need to have too much of analytical skills to go about with making this entire analytics for this study.
Excellent. Okay, so that seems fairly straightforward, right? So how are the how does the data visualization for this look, and how do you collect these data points? And once it's collected, what does the user do? How does he interact with this data that is presented?
So that's a really good question. So I have a really nice example over here. So usually validation of different sensors, especially temperature mapping, happens in a series of temporary sensors or loggers surrounding the fixed sensors on site. So I have a case study, a week's worth of study which has 4 fixed sensors that are surrounded around the entire plant. Following it, I have 19 different temporary sensors which are located in a cluster format surrounding these 4 sensors that will monitor the surrounding temperature just to make sure that the readings that these fixed sensors have been collecting all this time is validated or not. So visualizations, I have already one prepared over here itself. So in visualizations, once we provide this data set, it consists of the sensor's value, the sensor label, date, time, and even latitude and longitude. Our application is able to process this information and is able to give you really nice and descriptive dashboards. So I have one over here. So this is the entire study data that I have. We have 4 different sensors, A, B, C, and D. I can select the study period. So this was done in July for a week. We have the different analysis of these sensors, that is the maximum, minimum, and the average temperature recorded by each and every sensor over here. We have the highest temperature and the lowest temperature recorded. And we also see a timeline, a view of the temperature that has been recorded with a precision of 5 minutes over here for each and every sensor. Similarly, we have total of 19 temporary sensors. There are summary statistics, there are readings, maximum, minimum, a statistical significance test, whether it is to ensure that there is no direct correlation between the temporary data that we have collected and the fixed sensor data. That is, it's an independent test. And the magic over here, we also evaluate the deviation in the temperature mapping, whether it's a 5% deviation or not. And accordingly, we use our ML models to classify it into pass or fail. So we have one sensor that has passed this test, and we have 3 different sensors who have failed and have noticed more than 5% of deviation. And also, I have one more feature over here where I actually chat with this data as well. So let me provide a few queries. I have some really nice queries ready for you over here. So let's see, let me provide this one. So not only can you create a dashboard, but at the same time, you can interact with that data using generative models. These generative models are closed source into our environment, and they are able to let you literally chat with the data with a few simple prompts. So like I just gave one that, okay, create a timeline graph for the temperature ID at the warehouse dock, and also point out the maximum and minimum temperature over here. So it literally understood the problem statement. It has created the entire visual. It has also marked the highest and lowest temperature for me. It can also do a couple of things. You can ask it to perform statistical analysis like Fisher's test on a particular sensor. I can ask that as well. It was able to process that information, and it uses its own agent to give you concise controlled answers for your any query you have regarding the data.
So this is really a paradigm shift, because nobody would have used the phrase chat with data in the past, even like 5 years ago, right? So this is actual natural language that you're using to query the data points that you feel are relevant or vital for your use case, right?
Yes.
This is amazing. And even the response is pretty quick, right?
That's true. We haven't had any situation where you have to sit and have a cup of coffee and waiting for the response. So it's fairly fast.
Gone are the days of the rotating hourglass, yeah?
That's true.
Okay. So this is really quite a game changer if you think about how this operates and how the data is visualized and how one can query the data and gain insights. So this is quite fascinating. Now, given this solution that you've built with this framework, can this be kind of scaled up to handle massive volumes of time series data that would typically come from a manufacturing line?
That's true. We actually do have a feature for this. We have 2 different deployments in the cloud. One where you can provide your own RF sensors, and we can real-time process the feed from this data feed, ingest it, we can enrich it, we can do analysis on the fly, and we can store them into petabyte scalable warehouses. Right now we have deployment in Azure and in AWS. At the same time, let's say you are using some older sensors that are more traditional approach. They collect the data in memory and every week you log them. We also have features to ingest that data and make it a part of our inventory so that you can also do analysis on that as well. So sky is the limit.
Wow. And scaling it is just kind of, there's no specific steps involved to actually make this bigger. It just can easily adapt to a larger scale data volume, right?
That's correct.
Okay. And given that now you're talking about predictive analytics, can we extrapolate this to also include predictive maintenance at some point, Tanay? Do you think that's a possibility?
That's actually true, and that's what our team has been working on recently. So exactly how predictive maintenance happens is, right now, this is one of the use cases that, okay, I'm looking into 5% deviation in my temperature in the surrounding. So if I were to monitor few more parameters, whether it's vibration, whether it's torque, I look into the deviation. I have a ML model that predicts that, okay, I'm seeing this much of deviation. That means with the next month, I'm going to see this much more deviation. We have all these sensors data compiled together to a point where we can actually tell our user that, okay, at this line, this machine requires a maintenance in the next 2 months. Otherwise, it is bound to fail due to so and so reason. So that's how we can cut the time required for a lot of redundant maintenances. You don't have to go about every month going again and again for maintenances. And you can also avoid crucial downtimes and save a lot of money over here.
Very true. So you're being proactive as opposed to reactive, where you lose a lot of time. And another point you made was, instead of doing maintenance on a periodic scale, whether you require it or not, you're only fixing when necessary and anticipating that fix beforehand instead of doing it as a reactionary measure. That truly is a paradigm shift in the way we approach maintenance. That's fascinating. And we also talked about the automation agents being GxP compliant. So how do you ensure that this entire solution from soup to nuts is actually GxP compliant?
So from the point a user uploads the data and from the time we collect the data, the data is encrypted in flight and it's encrypted in rest in our data warehouses itself. We have a closed environment where the entire deployment is done in a private subnet. We have a proper cluster established that is, even though on a cloud, it does not interact to any internet or outside network in such a way where you would expect a data breach. Right now, considering AI and the revolving conversation around AI equals data leak, we have made sure that we use LLM and different generative models that can be deployed and controlled within the source environment itself. So you don't have to worry about something going out of your system and somewhere some other person suddenly finding your data out there. We have ensured from the GxP point of view that any data manipulation is well contained, well encrypted, and well secured.
Pretty amazing, because if you think about the space in which this can be used, all of your pharma, med devices, anything that's FDA compliant or any other facility that requires GxP compliance, this solution will easily lend itself to something like that, right?
That's correct.
Okay. This seems fairly well put together. Were there any challenges that you faced, when you were developing this solution?
So the most challenge that we face and why traditional methods still prevail is that you need to understand relationship between different data. So if I have two different temperature sensors, I have different latitude and longitude. Can the automation understand that, okay, these fields look similar? Maybe there is a correlation between it. These latitudes look similar. So can I bound them together in a cluster? Usually we always had a human being, an analyst getting these things done that, okay, I know that in the map there is this radius difference. All of these sensors are together. But with agentic framework, you can get these thought process controlled and concise so that we can build upon different relationships and we can do machine learning analysis in an automated and consistent manner. That's how things have become more beautiful and more transformative over this entire journey.
Makes sense. So gone are the days of, relying on human tribal knowledge and, making sure that knowledge is transferred from one person to another. So this kind of obviates that need and actually makes the process more consistent, accurate, and less human dependent, right?
That's true.
That's awesome. Okay. So this has really been an eye opener tonight. So in closing, I would say, as we've seen today, that predictive analytics isn't just about numbers and data. It's actually uncovering hidden patterns, like you mentioned, correlations, and driving decision making, guiding businesses toward smarter insights and strategies, and also kind of anticipating what challenges you may face tomorrow through this predictive maintenance kind of extrapolated view. And it's clearly evident from this demo that we've gained a glimpse into how powerful these insights can be if they're harnessed correctly. So remember, as xLM has just kind of demonstrated, the future isn't a mystery anymore. It's a forecast. And with predictive analytics, you have the power to shape that future with confidence. So thank you, Tanay. I think this was a true eye-opener. More to come on this podcast. Thanks for your time.
Thank you, Anandji.